Good morning or good evening, whatever time you are watching this. We are going to talk about the correlation. Correlation is a standardized covariance. That's why it's a measure of an effect size. And it's the strength of the relationship between two variables. So let's go ahead and look at our data first. Let's check our variables. IED is their ID variable, so we should actually change that to ID. Dan's quality of sleep, continuous, good. Baby's quality of sleep, continuous, good. Dan's grumpiness should also be on a continuous variable. I'm not sure why it's suggesting it's nominal, so we're going to go ahead and fix that. And then day, just the day of the measurement, 1, 2, 3, 4, 5, etc. Let's go ahead and look at our descriptives now. We'll pull all of these over. We're not going to split by anything. We're not going to ask for frequency tables because these are all continuous variables. Notice how frequency tables should be done with categorical variables. We don't have that problem. Statistics, go ahead and add our skew, kurtosis, Shapiro-Wilks, and get our plots. Okay, we'll ask for this too. I'm just going to take these out too. Okay, Shapiro-Wilks is good except for day, but we're going to look at that because that's a funky variable, right? It's just counting up the day. So it's technically not even a normal distribution at all. It's a different type of distribution. We'll get to that in a second. So Dan's quality of sleep looks a little negatively skewed, but it's okay. And our Shapiro-Wilks is fine. We could check our skew real quick. 0.30 by 24, 1.25, yeah, we're good. And I think kurtosis is good too. Yep. So Dan's quality of sleep looks not great, but it's okay. Baby's quality of sleep looks decent, and Shapiro-Wilks was fine. QQ plot looks fine. Dan's grumpiness looks a little positively skewed, but QQ looks fine. Now day is a funky variable. It's technically a uniform distribution. And that's why it looks so funky. And that's why we probably shouldn't even just include it in our analysis, but we can, right, to see if like there's a relationship between how all this works and the day of the year, for example, in the 100 days that they collected data. But look at how beautiful that line is. It's just not normal, but that's fine because it's a uniform distribution. So we've actually just looked at two of our assumptions for the correlation. Our data is normally distributed. Day is weird. We're just going to include it anyways. And the variables are measured at the continuous level. So to test our third assumption that the relationship is linear, we need to look at the actual correlations. So let's go ahead and do that, and let's run our correlations. So we're going to go to regression correlation matrix. We're going to pull all of our variables over. We'll leave it at Pearson. I want to flag the significant correlations, ask for a correlation matrix. We're just going to assume that they're just correlated, not that they're correlated positively or negatively. Okay, we could ask for our n as well, but the n is going to be the same throughout because we have no missing data. So I'm just going to take that back out. Okay, and now let's look at our third assumption before we go into our interpreting the results. Now, this is where we look at the underlying data, not the line itself, but the underlying data. And so right now this looks like just like a big blob, big blob, big blob. And that's why none of these are significant actually, right? None of these are statistically significant. This is a nice tight correlation. So this is going to be the strongest correlation followed by one of these two. We can check that, right? This is the strongest correlation, and these are pretty similar. That's because the kind of width from the line is a little bit larger versus this is tight. This is a big correlation between Dan's quality of sleep and Dan's grumpiness. We get our densities. This matches exactly our densities from here, right? Exact same density. And then we just get the correlations as well. So this is the correlation here, day by Dan's sleep, day by Dan's sleep, baby sleep and Dan's sleep would be baby sleep and Dan's sleep and baby sleep, this one. So these two are the same, this and this, this and this, right? So this is the diagonal, this is above the diagonal, and this is below the diagonal. Okay, so looking at the data, it doesn't look like there's any curvilinear relationship. It's either a big blob, meaning there's no relationship, or it's a nice tight line. So we've met the assumption of linearity. We've met all three of our assumptions. Now we can interpret our results. So we go back up here and we looked at, see that the day of the 100 days was not significantly correlated with any of them. But there's a strong positive correlation between Dan's sleep and baby's quality of sleep. And there's significant negative correlations between Dan's quality of sleep and his grumpiness, and baby's quality of sleep and Dan's grumpiness. So those are all three related to one another. Day's not related to anything. And so then we can write it up. So I had the write up here. I would say, I don't know what was going through my mind at the time, but I kind of dropped talking about day over here. I really think I should have added that just down here, day with its means and standard deviation. Just say it's not significantly correlated with any of the other variables. So I should have added that to my APA write-up. Keep that in mind. But otherwise, note what I'm doing here. One, a couple things to keep in mind, right? One, I am putting the descriptive statistics after each time I mention the first variable, right? So Dan's grumpiness, Dan's quality of sleep, mean standard deviation. Baby's quality of sleep, mean standard deviation. Okay. And then after I talk about the first correlation, then it's the actual correlation, and the second correlation, and the third correlation. But let's read it out loud minus the statistics. You might find it useful to write up without all the statistic stuff and then add it in, right? Because otherwise I'm giving some feedback to some folks, like, check your grammar. Like some people are getting fragment sentences. Some people, it just doesn't really make sense, right? So read it out loud. Dan's grumpiness, get rid of that, is negatively correlated with both Dan's quality of sleep and the baby's quality of sleep. Furthermore, Dan's and the baby's quality of sleep are positively correlated. Okay, so I'm interpreting that they're negatively and positively correlated. I could add more of the strength and say they're strongly negatively correlated. I could also refer people to a table. I don't think I have it in here. I do not. Okay. So I took the liberty of putting together an APA table. It's not quite right because we need to do some stuff. So APA, I forgot something. I always forget. So I always go to an online thing. Table 1 in bold. And then, in italics, correlations among the variables. And then I like to put the sample size here, right? Because it's 100. And then I have all my variables. And notice what I've done here. 1, 2, 3, 4, 1, 2, 3, 4. Because if I try to put all this text up here, it would add a bunch of lines. And we need to keep our space. And I could just go 1 and 1, 2 and 2, 3 and 3. That's not too much work. And especially when you got like 10, 12, 15 correlations you're trying to do, having the numbers is going to help you be able to fit everything into your table. Okay. Another thing I sometimes like to do is adding the descriptives. So let's do that because we have that here. Dan's grumpiness was 63.71, 10.05. We'll fix that in a second. Dan's quality of sleep was 6.97 and 1.02. And this is 8.05, 2.07. And we don't have day. I can go back up here. Back up here and get day. Day, the mean is 50. Actually, it really just doesn't make sense, but I'll put it in anyways. 29.01. Okay. And then we're going to fix all this. We'll make this fit first. And then I like to do the, under layout, distribute columns. Makes them distributed evenly. I sometimes like to bold this and bold this, but that's up to you. Actually, I'll just undo that for now. And then I want to show you something else. Take this out for a second. If I didn't do decimal alignment, this is how everything's aligned up. And notice how this just doesn't line up. It makes it, if you especially have longer, bigger tables, really hard to read. We want this to line up. Now, some people, you could just do kind of a space, but that's not quite right. This isn't a space, right? So really, we should be using something called decimal alignment. So over here, you should have this showing up if you're showing your ruler. So if you go to view and ruler, have that on, you'll have these alignment guides, which really helps with making things align properly. So we're going to click through until we get the one with the period in it. This is called decimal tab. And then in here, I'm just going to drag the decimal to about where I want the decimals to be lined up. And that's about it. Now all the decimals are lined up at the same spot in each column, column. So now it's much easier to read. And now these aren't going to mess things up either. Now, one thing to keep in mind if you're having struggles is if you do centering, it messes all up. So you always have to have a left alignment when you're doing a decimal tab. So now we have a nice APA style version of our correlation table. So I could actually put this into my write-up. Let's go back to our write-up. Let's do this. And we want this to be double spaced. So Dan's grumpiness, and was negatively correlated with Dan's quality of sleep and the baby's quality of sleep. Notice I don't have to talk about anything because then I'm going to say see table 1. Furthermore, Dan's and baby's quality of sleep are positively correlated. Correlated. And then we could write there was no significant relationships between the day of the experiment and any of the other variables. Good. So I can just refer people to table 1 instead of writing it all up. So that's another way we could go about, there we go. And we could add more strength, was negatively and strongly correlated. It's positively and strongly correlated. These are pretty strong correlations. Good. So that's our APA write-up. Note next week that you're going to learn more about APA write-ups, and you'll learn more about doing these tables. But this could be your write-up as well, referring people to the table. Okay, last little bit. If you meet the assumption of, especially like normal distribution or they're not continuous variables, then you could do a Spearman's correlation. Both Spearman's rho is the little Greek letter rho, and Kendall's tau are non-parametric statistics. They do things on a rank order instead of on the means and stuff. So you can do this really easily in Jamovi by just adding Spearman's and Kendall's tau B. We'll go back down. And you'll notice that except for Kendall's tau, the correlations are, let's actually get rid of this. I like comparing Pearson and Spearman. You'll notice that they're very similar. And it's because we meet the assumption. Kendall's tau is a little different. That's why it was just so different. But because we meet the assumptions, not surprisingly that the Pearson's R and the Spearman's rho are pretty similar. And then some additional information. Okay. You'll also be reading about the regression soon, but one thing in the correlation and regression is we can get what's called the R squared, which is the percentage of variance in overlap. So let's go back to just Pearson. The correlation between Dan's grumpiness and Dan's sleep is negative 0.9. Now, we should know already what 0.9 times 0.9 is, but we'll just do it really quick. 0.9 squared is 81. 81% of the variance in Dan's quality of sleep, actually, let's do it this way. 81% of the variance in Dan's grumpiness is related to Dan's quality of sleep. So like there's an 81% overlap. If we were to do a Venn diagram and we have the two circles, the overlap part of the two circles would be 81%. And then the unique part would be, 100 minus 81 would be the rest of it. And so 81% of the variance, let's go back to this, 81% of the variance in Dan's grumpiness can be explained by Dan's quality of sleep. When we get to regression, what will be awesome is we can actually use multiple variables. So it could be like 81% of the outcome variable, whatever it is, can be attributed to the combination of all of the independent variables. So we can find out how well do all of these variables predict our outcome variable. 81% is pretty large, at least in our field. I'd be lucky to see this in my typical day-to-day work, but cool. And then lastly, and I think I took it out of the homework, but let's go look at it. I don't think I have any of this. I think I took it all out. Sometimes you're interested in comparing the strength of correlations. Yeah, let's just see. Perform the test. Nope. Okay, I'll come back to that in a second. So sometimes we're interested in comparing the strength of correlations. I want to see is, for example, let's go back to here, is the correlation between Dan's grumpiness with Dan's quality of sleep stronger than the correlation between Dan's grumpiness and baby's quality of sleep. You can eyeball it and be like, oh yeah, 0.9 is greater than 0.57. But how could we test that? How do we know for sure? So in this case, these are dependent samples. So a comparison of correlations from dependent samples. So we could open this up. So we want the correlation from dependent samples, good. We want the correlation, this is 100, correlation between 1 and 2, 1 and 3, and then 2 and 3. So 1 and 2, because we want to compare Dan's grumpiness and Dan's quality of sleep, Dan's grumpiness and baby's quality of sleep. So Dan's grumpiness would be 1. So we'll go negative 0.90, negative 0.57. And then simply it's the relationship between 2 and 3. So that would be Dan's quality of sleep and baby's quality of sleep. So this would be 0.63. So we get our Z statistic. We interpret this just like we do like the skew and kurtosis Z scores. This is much bigger than 1.95. So there is a statistically significant difference in the strength of correlation between negative 0.90 and negative 0.57 between these two. And we could write that up similar to what we have. I guess I didn't really write it up, but there is a significant relationship. This is significantly stronger than this correlation because these are dependent samples. If you have independent samples, for example, let's say, we'll go back to the sample data set. So this one is like, is the correlation between English and reading scores the same or different between men and women? So we have 2 independent samples, men and women. They, no overlap in those samples. And we want to see if that correlation is similar in strength between the two. So for, let's see, men, we'll just assume this is men. The correlation between English and reading scores is 0.36. And for women, the correlation is 0.33. And the question is this statistically significantly different? Given our sample sizes, given the strength of correlation, and in this case, no, it is not. But if we're interested in those strengths differences, then we would do this type of stuff. But I'm not testing you on it, so get a feel for it. I've had to use this in the past. This is why I've incorporated it, because I don't want to just say, oh, 0.63 is higher than 0.57. Well, what if it's not, right? And actually, we could even test that, right? So, here. 100, but now we have 0.63 and negative 0.57, but then negative 0.90, and it is. 0.63 is significantly stronger. Well, actually, I wonder if it's because of this positiveness. Yeah, the positive is kind of playing with it, but even if we took that out, it's still significantly different. So 0.63 is more strongly correlated than 0.57, given the correlation between the two related variables. So we can test that type of stuff instead of just saying eyeballing it, because the eyeball test may not be accurate. Okay? Because you might have been like, oh, 0.63, 0.57 is a different 0.06. That's not different. But in fact, it is statistically significantly different. Okay. You got some examples that you could run with if you'd like. You could try, I don't know if I have you do it in the homework, but feel free to do a correlation matrix in your write-up instead of writing it up in a paragraph format. Although I'm going to have you do this specifically in the regression homework, I believe. So now we have some help in doing, and actually we could do this with the decimal alignment too. There we go. That's even better to read. Voila. Right. That's it for the correlation. Let me know what questions you have.